My name is Koschmann. I'm working for Siemens Mobility as a test engineer. Yeah, so testing is my task, also system integration is my task, and you see in the picture we are working in a transportation section. So that's not the classic IT, that's more applied IT, yeah, but there is also much more IT than you might think. So let's go. Yeah, nowadays each trip begins with code. It's not the booking code you see on your ticket, of course. Yeah, it's the code which is being prepared and tested by several people through years and years of experience. Yeah, and modern systems, modern rails, modern transportation systems are also moved by IT-backed applications. So, just to name some, of course, there is much more. It's just some points that I might mention about where is IT in modern railways. Yeah, of course, we have the operations management. That's just for the train control. It's just for controlling that the trains are driving as they should. They are not, for example, passing a red signal. It's of course for maintenance management, because the trains also needs quite high amount of maintenance every day. They are going to the depot, then they are being examined, and something is being preventively, or something is being repaired. Then, of course, customer service, ticketing, different things. Yeah, but what I want to say, for long years, railway was a classic mechanic domain. Yeah, it was no IT at all. Yeah, then the ticket sales began, and nowadays the systems that are the backend of railway are also digital systems as well. Yeah, everything began so in the mid of 1980s. Yeah, where we had some electronic devices already controlling the traffic in the area, and today it's even more. So sometimes it's about convenience, but mainly it's about safety. And what we'll examine today, or that will be our scope, is operations management, or let's say rail automation. Yeah, that's a generic term for this. This is about this is about that. Mainly, if you go by train somewhere or by S1 Berlin, you see something like that, many tracks, some web of tracks. That's what you normally don't see. That's the operational control center, yeah, where another colleagues are sitting and preparing your train rides in the background. And the question is, what is actually this rail automation, and what is here automated in the whole thing? Yeah, you see the trains are moving somehow. They are stopping in the stations, or they are just passing the stations, or maybe they are coming close to each other, but they, of course, don't collide. Yeah, and let's see how it actually works. Before I prepared, or Vitali prepared a whiteboard. Thanks him. And we will try to reinvent rail automation, just 2 or 3 minutes at maximum, and see what it is like. Who's familiar with that? Somebody? Okay, so I want to reinvent rail automation just in 2 or 3 minutes. Yeah. So does somebody know what is so about? What we need for trains? What do we need for control of trains? And what do we need to manage the traffic?
Probably sections should be under power, so which section is occupied by train.
Okay.
Signals.
Signals? Yeah, right.
Signals. Yeah.
That's good.
And, stop signals.
Stop signals, also good.
Rails.
Rails? Yeah, rails. Let's begin with rails. Let's begin with rails. Chains as well. Everything. So that's a track. Usually it's like double rails and some sleepers, but that's a single track, just symbolic. Yeah. So everything begins with tracks. In a simple track, nothing happens. Everything happens where we got a siding like this. Yeah, where the trains can meet each other. Let's say a train comes from here. A train comes from there. They are moving. And now is the question, what should happen? Of course, collision. No, not at all.
Exactly the opposite.
Exactly the opposite. Exactly. Therefore, Somebody said signals. Yeah, signals is good. There is a signal. Yeah, let's draw it like this. Really huge signal, which should prevent the train from collision. Yeah, the signals can show red lights, yellow lights, green lights. Well, it's it's a question. Different countries, different signaling system, and so on. But in fact, with the signals, we also have some. We call them points or switches. They are the places where the trains can go left or right, and the points are connected to the signals. Yeah. So at the very beginning, we should think about the routes. So this train number 1 should ideally go there. Ideally, yeah. And the train number 2 should ideally go there. That means there must be a system which excludes the situation where the first train goes there and the second train goes there as well. Yeah? And this system, or these systems, is not just the one, it's a complex of systems. This is called rail automation. Of course, there must be a point of control with somebody sitting there. And he's not just observing, he is also controlling. Yeah, so he has some control devices, he can set the routes, and these routes are then set for the trains. And then the trains will get green signals like that. What's missing? Some ideas? Okay, question?
Is it clear if the train goes to the switcher or in the red direction?
I'm sorry, please, once again.
Is it clear for train on which side it must go?
Yes, that is in a classic rail automation. This is being signalized by different lights. So if it goes straight ahead, straight through, it will be green. If it goes through a switch, through a point, left or right, it will be green and yellow, for example. Yeah, but in different countries there are several rules. Please.
Yes, I also have a question. For example, the signal lights are not working.
Okay.
And the train should know, depending on the direction, which side it should take.
Yeah, that's a situation which we call recovery scenario, where some of the subsystems is not working. Let's say the signal is not there. Yeah, how to move? We have radios on the trains, and the operator also has a radio in his house, so they can call at least. But that's a recovery scenario. Of course, operator cannot talk with multiple trains simultaneously. He can call with one train, a train 2, and they can somehow manage this, but this is too slow. Yeah, please?
Hard code in this system if something like unexpected happen on the right, it will always be red.
Exactly, that's also a very good point. There was just one more question, please.
No, I mean that depending on the direction, even nothing works. You do not have even the connection between the operator and the train. And depending on the direction, you should know which route you will take.
Let's say yes. Yes. Normally it works even without the operator. The operator is in background, is sitting, is preparing the routes, but the trains should also be able to move without the operator. Yeah. So he's controlling, but he's, let's say, for a recovery scenario where the signals are not working, he should operate and call the trains and talk to the people and explain. And to the second question, what happens if something happens here? For example, the train has got a route straight through, but this route is being occupied by a different train. Maybe like this.
Any connection between drivers? I don't know who drive the train? Between trains?
No. There can be a connection, so it's allowed to call, from one train to each other, but usually that is not needed. So the most important connection is that to the operator. Yeah.
Probably we need some priority queue, like who goes first if nothing works. Like I mean, like if in this situation, so
with a ghost train.
The train is occupying here. There is a solution here.
Yes.
And should be generalized, and so like in this case, this goes first, this goes second, this goes third.
Exactly. Well, the queue is of course also a good thing, but this is already the disposition. Yeah, that's a dispositive. But we have to think about safety here. So if the train has a route prepared, this train has a prepared route there to the right, and if something would appear here, it might be a different train which took a different route and did not obey the signals and the rules. Then immediately we should have a red light here. Yeah, and the train should be stopped as well. Yeah, so there must be some kind of an appliance also on the train here, which is capable of reading this and reading this somehow. So this is everything is a network at the end. So the train can somehow feel the signals. There are special appliances which are doing that. And the train should get a signal when his route is, let's say, released. We tell the route is released when this route is not active anymore. Because once this route is set, it must be free the whole time until this train really goes into the route and arrives where it should. Yeah. Okay, just at a glance. We're more than 3 minutes, but there's more to come. So, as I told you, we have multiple elements on the track. We have the signals here. That's a signal. That's a modern signal here. I think it doesn't work with a laser pointer, but anyway, it's a more recent, well, an older signal, which you can still see in Germany at older tracks. We have some points or switches. We have different naming for them in American, British English, points or switches, but they are the same. They're the places where the train can switch from one track to another. We have, of course, the level crossings where roads are crossing our railroad, where the cars are going. And I think someone told that as well, the track occupancy. Yeah, it's also a very important point because the track occupancy is the point where we check whether our route is free or not. Yeah, so for example, if a train is here, somewhere between these two signals, then the signal cannot show green anymore. Yeah, then this route is occupied. And we have to feel this occupation as well. This is being done by axle counters or by sensors. Yeah, so some sensorics is also in between to check whether there's trains there or not. And at the end, all those elements are going here in this house with a nice green roof, and this is called interlocking. Yeah, it's quite a strange word, but interlocking means actually that all elements that are controlled, all elements that are under control, are being taken together in one point, and we are locking several elements against each other. So if we think about our previous picture, we have a route which is excluding a different route. Yeah, the trains should not meet, they should not collide. So if the first route is set, it is locked. And earlier that was done with some, really, I call it steampunk, electromechanic and just mechanic hardware. And it was also really hard work to pull these switches and cables and ties, but that was the mechanic logic. Question?
I have two questions to ask. The first question about this picture.
Yes.
In this process, they need the human interaction to make the decision, to interlock the system, right?
Yes, the operator.
My second question is, we knew like how the operating system works. For the railway system, are they using the same model for managing different trains, like the way that we used to do in computer operating system by using first come, first serve, and then we prioritize as per the job, and then we make different actions? How it works?
It works. Yeah, I would like to simplify a question a little bit. So, for example, we have some trains that are like first come and first serve, but at the railway we have timetable. Timetable is the Bible, and timetable tells us which train goes first, which train goes second. The fun begins when the trains are late. Yeah, then we have to decide. Maybe the first train which came first should not be served first because it's not very important, but the late train who comes second should be pushed straight forward because it has to go fast, or is it an ICE train, whatever. That means it's still human that controls those sequences. There is a timetable, normally, yeah, and the timetable is looking for the trains that are going through the line. But if something goes wrong, I mean wrong in terms of timetable, not in terms of safety. If a train is late or something else happened that the train cannot go further, then a human should decide what happens. Yeah? In Germany, we have several operating control centers that are sitting the whole day and observing the trains and are looking, okay, we have a delay here, we have a delay there, but we should compensate the delay. There are some advisement systems, yeah, please.
And they cancel the train, right?
And at the end, they might cancel the train, but that might happen. That might happen as well. Exactly. So, just for you. Earlier, it looked like that. And it was really like pulling and pushing and turning some small knobs and values and lamps. Steampunk. Good. And nowadays, we have an evolution. Yeah, from the mechanical interlockings seen here on the left, with the levers, with the mechanic ties and everything. We moved on after, so mostly in the 50s, 60s, we moved on to relay interlocking. Relay interlocking is just like a relay computer. That's a computer working with, how do you call it? Relay logic, analog logic. Yeah, so you have electrical circuits that are, it is the same like XOR or and if and so on. Yeah, but already done with some kind of electricity, and there were such operation control centers with TV sets and with big printers and telephones. Yeah, nowadays it's all digital, not all, but mostly digital. You have people sitting on these operator places like this. They might be, for example, 200-300 kilometers away from the actual line. Yeah, and they are controlling the traffic. They can have cameras, they can have some devices, but mainly they must not even be there on the place where the trains are moving. Yeah? And the future trend is, of course, here the IP network, where, let's say, every element in the whole network is like a small computer which is controlling itself and which is networking with the rest of the system, and we can reach every component at every time. That's the future, but this...
TCP or UDP?
Trains, UDP, come on.
UDP.
Data is really sensitive and you need to force it through, like something happens.
No. As far as I know, so the trend is to use TCP IP here in those networks, and on the trains directly we have even proprietary systems. So let's say this is needed to reach everything everywhere. So you have to plug in and at a certain point of the system, and then you can reach any station. Yeah, but inside of the stations there might be some proprietary controls and so on. Good. Well, another picture with the schematics. That's how actually this thing works, which we recently have reinvented here on the whiteboard. Yeah. So we have a train. Here's a blue train, nice blue train. Here's interlocking. That's a house which serves and hosts all components that are on the track. Here's a track, and here is also a sending mast for GSM-R. If somebody doesn't know, GSM-R is the GSM for railways, yeah, which should be replaced by 5G in 2 years, but it's still active. Let's see which system does actually what. So interlocking, as previously mentioned, is controlling signals, points, tracks. It's observing whether the track is vacant or occupied. It's a redundant system because it has to run 24/7. So there is nothing which can stop interlocking from working normally. Unfortunately, that happens as well, and then we have really, really big issues. So ideally, that shouldn't happen. Therefore, the system is 2 times 2 redundant. So there are 2 machines running in pair, plus 2 additional machines running in pair. And this is a special software written. It's a real-time operating system, which is, of course, also a secure one. Next one is a radio block. Abbreviation for this is RBC. It is managing all trains that are driving on the line with radio. So every train has got a radio connection to this radio block center. And this RBC basically gets information about routes from the interlocking and sends this information in simplified form, means speed and distance, to the trains. And on the train it looks like this. So train driver, as he's driving, he's seeing his permitted speed right now. He's seeing a forecast, which should happen in the next, let's say, 2, 3, 4, 5 kilometers. So the distance is also there, and some additional data as well. Radio connection is encrypted. There is special encryption for this, and also keyed. That means not every train can talk with every radio block. There's a special connection, so every train gets a key only for the radio block where it has to drive, not vice versa. So the train has sensors for odometry to, of course, to calculate the speed, to see how far it moves. And orientation on the tracks is being done by passive circuits. We call them Eurobalises, yellow points. The next time you'll drive S1 Berlin, pay attention to these yellow blocks on the railway line. Maybe you saw already them. These are Eurobalises as well. So they are used for positioning. They are completely passive, like RFID. Yeah, so if the train is passing such a balise, then the train knows, okay, I am at track somewhere. Yeah, and the RBC knows, okay, I have a route for the train. I will send this train a movement authority, how we call that, and then the train knows, okay, I have to run with 160 for another 4 kilometers roundabout. This is how the modern system works. Of course, it's not yet everywhere, but this system is also desired by European Union for all countries in the European Union, and this is called ETCS, European Train Control System. Yeah, so this is our aim for 2040 roundabout right now, to implement this system on the main corridor lines throughout whole Europe. Good, let's move on. I thought a little bit before I prepared this presentation, and I thought that I will show you a picture of something which is more or less, not really dangerous. That shouldn't happen. Yeah, that shouldn't happen at railway, but unfortunately that happens as well. I will not show any horrible pictures, but well, classic IT, rail IT, you see the difference. Higher cost of failure. Yeah, so our software must be as good that shouldn't happen. That happens due to several reasons. About this a little bit later, unfortunately. Yeah, but yeah, also the consequences are quite different. Yeah. Mostly it's if it comes to human lives, if it comes to some train movements where people could be potentially injured, the people are also being prosecuted for this. Good, and because it's so important to have the safety approach, there are some Senelec norms. Senelec is an organization which is norming the electricity and several also, let's say, applied IT processes. And these norms are now European norms, therefore the EN. And this is our approach, how we maintain quality and safety. It's a part of European standardization. It has some parts. It has some parts about risk management, compliance, reliability, of course, and maintainability as well. The main part is also always safety and security. And every time we are talking about systems of high risk, such as railway, this norm has to be applied to the whole development process. Yeah, this is now the point where we are talking more about IT, than about classic railway. But this is a process which is valid, and we have to maintain this process as well. I will explain how it works. First of all, we have a safety life cycle. Yeah, this is not really new to QA. Yeah, everything begins with planning, then comes the development, then verification, validation. But in opposite to, let's say, classic approaches like waterfall, which was already mentioned, and so on, we have clear levels of safety integrity. Yeah, there are systems that must be just, let's say, as safe as needed. Some, I don't know. Yeah, for example, a rail. Just a simple steel rail must be just a rail. It has no special safety integrity level. But a system which is organizing and managing the traffic in a dense area, like in Berlin, it must have the highest safety level, because if the system, let's say, doesn't work, we have a big problem. Yeah, so these levels are ranked from 0 to 4. And depending on which safety integrity level is applicable for the current tool we are developing, we have to obey more or less rules. Everything must be clearly documented, and afterwards it will be verified, validated on one hand by quality management, on the other hand by different assessors, which might be external as well. I will show a little bit more on the next slide. And we have to understand the configuration. As a configuration, every time the configuration is changed, there must be a configuration management which tracks the changes and which might be also understandable. So just imagine there is a software update on some station, so somebody changed the configuration, nobody knows what happened. Yeah, and later there is, I don't know, system doesn't work, trains are stopped. So what happened? Nobody knows. Therefore, this part is not really the most loved part of the whole thing, but it's also important. Yeah, and the neighboring norm is the Euro norm 50126.1. That's the Senelec development model. I think it's familiar to some of you. No? Yes, certainly. Okay, so this is actually how we work. So at the left we have, this is a V model. It begins here, goes down, and goes up. So it begins with a concept. Then we have the tool, let's say. It will be manufactured or coded. Then we have to integrate the tool, validate, do something for the system acceptance or for the certification, and then it goes up to the decommissioning, yeah, where the system has reached the end of life cycle and is being scrapped. Very important is that it is a little bit like a mirror. Yes, I mostly work here in the integration and system validation, and I have always to look at the neighboring side of my V, to the other side of my V. So if I'm validating, if I'm testing, I have to look on the specification. What actually I'm doing, yeah? What I'm testing against, what is my specification, what is my test actually for? So that's always my question. Yeah, integration part is also very important because I do system integration as well, but there I think it's a little bit easier to see the architecture and then to look what I want actually to build. Yeah, test here, exactly. And let's say if we want to test for some appliances which are for the railway. I have no railway tracks in my lab. Therefore, I'm working with virtualizations. Nowadays, it's quite easy. We have digital twins, virtualizations, which allow us even to virtualize proprietary operating systems and proprietary platforms. Because the hardware we use in the railway is, well, industrial built, but these are not COTS PC, COTS. Yeah, the special PCs, special platforms, special appliances. Therefore, in the lab, we are working quite much with virtualizations. And that's such a system which I have in my lab. I'm loading a topology model. This is where I know how I can drive these routes and which routes are possible. Then I have a train onboard unit, which is virtualized. Yeah, this is the train onboard unit which calculates the speed and distance. Then I have the trackside unit with interlocking. You remember interlocking? And the RBC, the radio block center. And this is being put together by means of a GSMR emulation, which has the same bandwidth. So we are not necessarily faster than reality. So everything is matched up so that it's as close as possible. Yeah, and of course there's a 3D as well, and some displays, drivers displays here, where you can play around and drive the train directly in the lab. Yeah, and of course, not only driving, also some operational control systems like on the interlocking are possible. And it's also possible to test every component and especially the absence of every component. Yeah, what happens if I don't know, if the RBC has a malfunction? It shouldn't, but what if? Yeah.
Netflix chaos monkey, but
I'm sorry?
no, like Netflix does chaos monkey when they turn off systems randomly, but not live.
Ah.
And in the environment, yeah?
Okay, check. It depends. It depends. Mostly we have to know what we are testing. Yeah, therefore we have no totally randomized tests. So we are trying to write the tests as sophisticated as possible. but there are some random issues as well. Like always in big labs, something is not working and nobody knows why. Theory and practice. That's how it looks like. In my lab, we have bigger systems with a 3D view, with a train driver's monitor, with train driver's desk. We have smaller systems. That's a Microsoft Surface. Just flipped around with a 3D in a separate TV set. That's actually for Microsoft Trains or for I don't know. Train simulator. That is just like a steering wheel for cars, but for trains. Yeah. So this is my work with virtualization. And I think I will tell also a few words about how the system is organized in terms of configuration and languages. So what we saw in the previous slide, before the previous slide, is overall virtualization. So we have to virtualize the components that are playing an important role on railway tracks. These are mostly tailored solutions written in C++ or C#, what we use there. And this is being written mostly for us or on demand. So we are hiring somebody from our developers, external ones, and they are writing these virtualizations for us. Then after my infrastructure is there, with infrastructure I mean actually this thing, yeah. So this is what I have in the lab. So every component is there in virtualized form. After that, I can write scenario scripts. Right now we are using Ruby for the language. Python is also used for some tools and functions. And this is where we describe what we're actually testing. Yeah, so here in this scenario script, they are telling the train begins at signal A, it goes to station B and should stop and maybe resume, and so on. And last but not least, the configuration files. Because what we test, we are not testing just for fun. We are testing also real configurations which will be later used on the real life. Yeah? And these configuration files are original and genuine. So what is taken here, after the lab, it's being taken on the systems outside and put into operation. Yeah. That's very important because I can virtualize what I want. It's nice and fun. You see, we have nice trains running, but it has no sense if we don't use the actual configuration files. Yeah. Question?
My head is full of questions.
Full of questions.
Let's start from your questions first. Later we'll have the conversation. What framework did you use for the virtual machines to test that system? Because as you mentioned it, you need virtual machine for the simulations, right? So for
That's
the
right.
simulations, what tool did you use?
Well, we use VirtualBox and VMware, but only for systems that are Linux-based. So
every single time you have to ask the developer team to integrate the VMware with your devices.
Well, yes and no. That's the point. We have some components, some devices that are running Linux. Okay. There, I think we can use VMware or VirtualBox, but most of the systems are proprietary. So it's a proprietary OS, and therefore the virtualization has to be written as a framework, especially for us.
Moving to the train railway system. For the
Yes.
testing side, what structure did they follow? What methodology are you guys following?
I'm sorry, could you repeat, please?
What methodology which methodology
methodology.
are you guys using?
Yeah, methodology. Well, this is nice. The best question. Actually, this is our methodology. So this is the most important methodology we should use. Yeah, if you mean different approaches to testing, I don't know, ticketing, Kanban, and so on, that is of course applied as well. But most important is this one. Yeah, this Anelek. Please.
I have a question. I always wondered that. We know that self-driving cars are at 80% complete and will stay there because the last 20% are the hardest, all the random stuff. But railways are much more controlled, and I always wondered why are not we moving in the way of just making it fully automatic?
Yes, super good question. Actually, we are fully prepared. Yeah, for automated driving. And if you go to Hamburg on the line S21, you can also drive an automated train there. There's still a driver sitting there, but I think the biggest problem is now the juridical part. Yeah, because the legislative systems are limiting us from driving the trains completely autonomous. Yeah, someone has always to sit there in the front and control. If something happens, someone should be there. Yeah, that's the biggest problem. Otherwise, there is also some grade of automation. Yeah, grade of automation 2, 3, 4, and so on.
So there's
Everything
no
prepared.
technical, it's just Luddite stuff.
It's no.
Actually, it's possible.
From technical point of view, no problem.
Lost credit card, so if you want to
Well, but in other countries, it is the same. We have also a running system in Budapest and the Metro 4 in Budapest. In London, the Thameslink line is also based on our equipment. In Paris, lines 1 and 14 are running with our equipment. I think, and what is very important part in the metro system, which are closed in tunnels, it is easier because you can certify the system. Nobody should be in the tunnel while the trains are driving. Here, if you go to Warschau Straße, people are just running through the tracks and nobody cares. Yeah, they shouldn't, but yeah, if they are hit by a train, somebody has to answer this. Yeah, and that's the biggest problem. Please.
Yeah, thank you for your presentation. My question would be about defect leakage ratio. So,
Okay.
I understand your system is very crucial. So, what is your acceptance criteria for that?
That's what I wanted to show actually at the next slide, because it was still not the last. Sorry, but we are almost coming to the end. Yeah, we can spring over field testing because it's hard with the time. Well, some tests are still being held in the field, of course. Yeah, because not everything can be simulated in the lab. We try our best, but some test cases, I don't know, weather conditions, some human factors, network instability, and so on. This is what hinders us from test the complete thing just in the lab. That's how it looks like. Yeah, it's also me there. Yeah, mostly at night, mostly at bad weather conditions, but
at night, mostly me.
yeah, or something like that. So I think in the last 2 or 3 years, I spent, I don't know, 12, 13, 14 weeks just on testing for the trains. But for 2 projects, no, for 3 projects. For 3 projects, and it's quite fun, but it can last the whole night. So beginning at 8 o'clock and ending at 6 or 7. So quite sleepy afterwards. At night, because no trains are driving at night, or no important trains are driving at night, so we can use infrastructure. Yeah. And if it opens, just 15 seconds of cab view sequence, the quality is not very good, but that is what I'm doing. The driver is driving, I'm observing the software, I'm observing how the software behaves, I'm observing also the signals, the points, the routes, and I'm making some notes, what is okay, what is not okay, and this is of course test operation.
Can you slap the driver?
Just well, I think it's not a good idea because otherwise they won't work with us anymore. Yeah? And so it's good. So last one about the certification and how it's being put into operation. Yes. It is about assessment and certifying. It's in the European Union, we have a tight juridical field, and also we have some TSI, that is the technical specifications for interoperability. That means that all trains and all rail automation systems from any manufacturer must be, of course, highest quality, and they should be compatible with each other. Yeah, so this TSI regulates. It's a little bit against the market, but it's okay. Yeah, because we have much more progress than just stupid business. Yeah, this TSI regulates that all subcomponents are working together, and we have defined interfaces between the components. Therefore, the train can come from us, the interlocking can come from different manufacturer or vendor, and so on. Yeah, and it's very important to maintain and make it better. Apart from the TSI, which is valid for the whole Europe, we have some NNTRs. These are notified national technical rules. For every country, these are different. For Germany, Eisenbahnbundesamt is caring about this, the German Railway Authority. In other countries, in other authorities. And for the TSI, there are the so-called notified bodies, special organizations which are caring about just about certification for the whole EU. Apart from that, there is an independent safety assessment, which is mandatory for every project in rail automation. That must be done by an external bureau, engineer bureau, which comes and makes an audit. What we are doing, what we are testing, who are the testers, what is the proof of competence of the testers, who are the architects, who are the validators, yeah? Who is doing quality management, and so on and so on. That ESA part is important as well. So here we are securing the fact that everything is developed and tested like it should. Last part is an ASPO, Railway Assessment Body. It makes the risk management. Yeah, risk management, we had that already some slides ago. The risk management is also prescribed by the EN 5128 norm. So, and there is also special CSM array risk assessment from the European Union. And at the end, it looks like that. Yeah. So here at the lowest point, we have the system which is tested successfully in the lab, and we wrote all our protocols, and already some assessment was there. So we have at least a certificate of conformity or declaration of conformity for one component, second component, third component. Then we have a national verification for the same components. And we have also safety or risk assessment again for these components. Then it comes to the next stage. There, these subsystems are being taken together. Subsystems, I mean, for example, track devices, some signaling devices, points, and so on. It's being put together here, trackside system, CCS, and the whole runs one more time. So we have a TSI verification for the whole European Union. We have a national part for every country, if the country has some special rules. And we have, again, an independent safety assessment, the ISA part. So after that, we have a certificate. Actually, I have some explaining slides. After that, we can meet these control, command, and signaling technical specifications for interoperability. So that's already the pre-certificate. And this is the authorization of placing in service, which is being carried out by ERA, European Railway Authority, which is responsible for all countries in the European Union. Yeah? So it also looks on this part, and this part, and that part, and tells, okay, now you can go, now you can build everything on the line or in the network, and it can go into operation. Quite complicated, and takes years for some lines. So, questions? Thank you very much. I think you were the first.
Can you tell us a story about your biggest field failure in Siemens?
Well,
One of.
yeah, we actually we had none of them, or not such a big ones. But I can tell about the situation where we were testing in the field, and our system was, of course, in a test stage, and we had to test one thing for which the train had to be stopped. The train definitely stopped, so there was an external signal coming from the line automation which told the train just to stop immediately. That's an emergency stop. The train stopped, but we couldn't drive anymore. So it was actually a problem on the train side. So something happened with the controller device, which was actually not from us, but it's not important. Important was the thing that it was already before the rush hour in the morning. We were almost done with the tests, and that was the test we wanted to do. And the line was stuck. Yeah, we were just standing with the train, and the trains could pass only on the second line, but not on the line in which we were standing. So the locomotive driver has gone completely mad and tried to make everything he could. At the end, we just powered the locomotive off and stood there for 10 minutes or 15 minutes, and then repowering helped, indeed.
Turning the computer
Yeah. Turning the computer off, not exactly. But it's a locomotive. There are so many computers that even the powering off takes, I think, 5 to 7 minutes. You have to turn off this, turn off that, and then you have to go into a machine room and then make some switches. Yeah. So it's really. And the operators were so angry because we stopped, I think, 10 or 12 trains which should have to go in the morning rush hour. But yeah, so we we were quite, yeah, smashed. Question?
Yeah, I'm just wondering, have you started or considering using AI for some parts of this process?
Ooh.
So like writing test cases or something like that?
Yes, writing the test cases is a good idea. Actually, we have our own generative AI already. This is Siemens AI, yeah, which is for us. And we can work also with documents in this AI, and it doesn't tell the documents a whole other word. Yeah. We are also already a little bit empowered to try it more and more, at least for writing some technical documents and test cases. I think is a good help, at least for the beginning. If you are completely clueless and sitting before a document, some architecture you should draft. It's really good tool. Yeah. For the rest, for the important part, I think it's a little bit too early. Yeah, safety approach. Please.
You said about the certification, and it is related to the trains as well. And how do you set up it, or how it should be set up for the old trains to have go through the certification, or it just related to the new one?
No, it's related to everything which is new, but also relates to what is being changed. Yeah, so at some point, certification was early as well. So even 20 or 30 years before, even when the European Union was not so big and so present in our lives like today, there were some certifications. In Germany, it was done by Eisenbahnbundesamt, Germany Railway Authority, or Federal Railway Authority of Germany. In other countries, there were special companies or authorities for that. Now it's already a little bit better because it's, let's say, much more homogeneous for the countries. Yeah, there is this one procedure for the whole European Union, which every new system or every change system has to run through, and this is fine. Yeah, depending on system's complexity, it can take less or more. Yeah, but it's like this. Please, once.
Is there any test kits there listed? If I have my own train, the old one, and I decided to use it on the rail,
Okay.
will you identify my machine?
Well, this is again a question which refers to the whole legislative system. Yeah, no train can drive here without a safety certificate. Yeah, and every train belongs to somebody. So somebody means Deutsche Bahn, ODEC, S-Bahn Berlin, Niederbarnimer Eisenbahn, whatever. There are so many railway companies in the whole European Union, and in Germany, Flixtrain, for example, exactly. So these companies are responsible and they can go on track. Yeah, and before they can go on track, they have to show the regulatory organ, which is Deutsche Bahn Infrago, the infrastructure management. They have to show their safety certificate that they are allowed to drive trains, and then they have to apply for a timetable. Yeah, they cannot just call the operator and tell, "Oh, sorry, we are here in the depot. Can we go once to Erkner, please? We want to have a grill on the Müggelsee." Unfortunately, it doesn't work like this, but there is a principle. Mostly all trains that are driving regularly, means every day at a certain time, they have their used timetable, which is valid the whole year or half a year or just the summer. And there is also such a concept of ad hoc timetable. Yeah, you can apply for a timetable to go, but you have to wait. First, the trains will be served which have their regular timetables and which are planned. So it's hard to have an own train, but there is a locomotive driver in Oldenburg in northern Germany who has his own locomotive, and he is his own operator. So he's driving around with the locomotive and he's transporting goods. Yeah, so he has contracts with some companies, picks up some cars, brings the cars elsewhere, and he's earning money with this. So very special, but not very normal, unfortunately. Please?
I have a question for you.
Yes.
As in software tester, how do you map their standards to test, to write test cases from your end? Because from their certificate, it's a lengthy documentation.
Yes.
So you have to map your test cases with their documentation to set the validations to make sure the robustness from your side.
Yeah. That's also a big task. Yeah, that's right. we have complete teams of documentational and configuration management that are sitting, and quality management as well, that are sitting and just matching the documentations between the processes and between our verification documents.
So every single time whenever you have to write a new test case or scenario,
Not always.
Getting data from them.
Not necessary. You can also take over some older components from this. So it's not necessary, but you have to cover all architecture which was defined at the beginning. So at the beginning there is a concept, an architecture, and some, let's say, requirement, specification, or list of requirements which we have to cover. Yeah, and then upon these requirements, I am, for example, writing the test cases, and then I am performing the tests. Yep.
Folks, let's stop
Folks.
the questions. We need. Thank you so much.